A circle is inscribed in a quadrilateral ABCD in such a way that it touches all the four sides. The question is, what is the perimeter of the quadrilateral? So now, when we see the question, we can think of the quadrilateral which may be a square, because in a square all the sides touch, but it may not essentially be a square. It can be a different kind of a figure, such as the rhombus as well. So what we have to do is quickly understand what kind of quadrilateral we have, and it is touching, the circle is touching all the four sides. So let's quickly draw the figure. Here we have a circle, and let's quickly draw the sides in different ways. So one side we have such as this, and the side we have such as this. The third side could be this. I'm trying to draw a quadrilateral which does not qualify to any particular property, so that our assumptions do not play a great important role here. So I've drawn a figure that is a very generic kind of a quadrilateral. Neither it's a square, nor a rectangle, nor a rhombus. It's a very weird kind of a quadrilateral which does not qualify to any standard properties of quadrilaterals that we learn. Now the question is, ABCD, it touches all the four sides, A, B, C, D. Now let's quickly start using the properties that we know of and the properties of the tangents, because here we see all the sides are tangent to the circle. So the properties of tangents say that from any point a maximum two tangents can be drawn. So you can see that from all the four vertices of the quadrilateral we can see two different tangents. The point of tangency when joined with the center always makes a 90 degrees. So let's quickly make that construction. That means I'm going to join all the point of tangencies with the center, and I'm going to mark all these angles 90 degrees. Now once we have done this exercise, so this angle is 90, this angle is 90, this angle is 90, as well as this angle is 90. Now the next part of it is that the tangents drawn from any particular point, the two tangents that we're talking about, both will be equal. That means if we call these points P, Q, R, S, then BP will be equal to BQ. Let me write it here. BP is equal to BQ, and CQ is equal to CR, DS is equal to DR, and AP is equal to AS. So these are several things we should know, and we should always put the markings here. So these two parts are equal. So I'm trying to put the markings with different colors so that we can visualize them. These two parts are also equal, and similarly these two parts are equal, and the fourth marking we can put as these two markings are also equal. Now what is the perimeter of the quadrilateral? We need to find out the perimeter of the quadrilateral. That means if we could find out several length of tangents, we can answer the question. Let's look at these statements. The first statement says that AB plus BC is equal to 10. When we see AB plus BC is equal to 10, now let us see that AB can be broken down as AP plus PB, right? Because these are two parts of it. BC can further be broken down as BQ plus CQ, and the sum of them is 10. So the AP will also have the length equal to AS. That means it solves the purpose of calculation of AS. And this BQ solves the purpose of calculation of BP. But BP we already know, BP and BQ are anyway equal. So CQ basically becomes equal to CR. Now what are we left with is, neither do we know the length of DR, nor do we know the length of DS. And DR and DS are going to be equal, but since we don't know their lengths, that is the reason why we say that the first statement is not sufficient to answer the question. So option A and option D can be eliminated. Now we are left with three options, option B, C, and E. So now let's quickly check the second statement. Second statement, on the other hand, says that AB plus CD is equal to 12. When we know that AB plus CD is equal to 12, AB can further be broken down as AP plus BP. CD can further be broken down as DR plus CR. Now what are we left with? We are left with BC and we are left with AD. But you see that AS and DS are equal, and now AS and AP are equal, and since we know AP, so we know AS is a part of it. Similarly, we know DR, so we also know DS. That means this line AD is taken care of. AS plus DS is AD. Similarly, now we are left with the length of BC. Let's quickly see. So CR is same as CQ and BP is same as BQ, which means that now we have these four lengths and the remaining four lengths will also have the same sum. So if it is 12, the sum of the remaining lengths will also be equal to 12. That means the perimeter is going to be 24, and hence the second statement alone is sufficient to answer the question, which gives us answer of the question as option B. Happy learning.